Hey everyone, welcome back to your Dawn of Autonomy podcast. I'm Dawn Zoldai, your host, the CEO of P3 Tech Consulting and the publisher at Autonomy Global. We just ended a great month that we dedicated to the theme of security, sponsored by Echodyne. And now that it's July, we are in a month that we're focusing on global ops. And FIXAR is our month sponsor. We have with us here today Basil Fainveits. He is an incredible person. You're going to hear all about him. He is the CEO and developer of multiple drones, and we'll learn more here in a minute. And then, of course, Maggie Schuster. For those that have been a fan of this show and of our former Drone Law Connections Clubhouse, you all know Maggie because she used to be our host, but now she's in a brand new role at FIXAR, doing great things for them in North America with these amazing drones that we're going to be talking about today. So thank you both for being on the show today.
Thank you.
Thank you.
Absolutely. So what I want to do before we start talking about FIXAR as a company and all the drones that you make and why they're so unique in the global scene, I'd like to talk a little bit about each one of you individually. So Basil, let's go with you first. Can you give us a little bit about your personal background?
Well, I came to this industry through the air modeling sports and activities in remote controlled air combat games, where I became one of the best pilots in Europe. And when you create these models in your background, you can also not just develop, but also pilot. So I can pilot helicopters, multi-rotors, airplanes, both the remote piloting, first-person view piloting, and general aviation piloting. So, but mostly I'm the math guy, which started with applied math and figure skating in my background. So I was a skater previously.
Oh,
so
wow.
came within my career for a long time since my childhood. So that's to be in short.
I love that. You've got the artist side with the skating and the math and then the piloting. quite the renaissance man, Basil. I love your background. So Maggie, over to you. Tell everybody just a little bit about yourself for like maybe the two people that don't know you that are watching the show right now.
Right. Well, again, I've been in this industry for about 12 years, got my 107, and became immersed with women in drones. And then, of course, I think the biggest advantage is talking to all the different companies and the CEOs and, the entrepreneurs in this industry. And I want to tell you, that's why I was attracted to FIXAR, because first of all, Basil doesn't say enough about him. He's amazing. And having somebody in this industry that is a visionary, that is the key. He is a visionary. He sees things so amazingly different. And when you guys see the pictures and the performance of especially the 025, it is nothing like you've seen before. It's designed totally aerodynamic. I mean, Basil has a really understanding of how planes fly, because he used to build model planes, and that's how he got into this industry. He kept winning, like prizes, and he kept going further. And again, as a visionary, he looked at things differently and addressed them. And that's why I'm so excited about being part of FIXAR.
Well, that's awesome. And they're lucky to have you, Maggie. And that's actually a great segue to talk a little bit about, FIXAR and the vision for it. So Basil, back over to you. Before FIXAR became a global brand that's in over 25 companies, it began with that vision. So what inspired the idea for FIXAR?
Actually, that is very simple. The idea is to help people. And to help people is not just help people save their lives, where nowadays drones are mostly related to some defense border control stuff being popular for search and rescue missions and operations, but also how to make this technology usable by the people who are not making and building models, who don't have this applied math background, or let's say even not for and easy skaters. Yes, so for any person to be really using the systems, they do not need to be pilots. They need some simple tools, easy to use tools. And at the market, actually, well, maybe you remember, there was a boom of quadcopter systems. Yes,
there were, yeah, in the early days, for sure.
and in the early days, yeah, and they became popular because of simplicity. Yeah.
Yep.
So the question was, can we build the UAV that is simple, which means takes off and lands vertically like copters, or even more simple than copters themselves, but flies like an airplane, having these endurance characteristics and long distance flights characteristics without complex mechanical parts or tilt systems or any other dead weights, which typically most of the VTOL systems have, because, you know, most of the VTOLs, they are systems of compromises. And what others control by hardware, we wanted to control just by software. That's why like applied mask comes in. Yeah, when you have a very simple means reliable and robust hardware parts, that means that the software should be the key point here. But software is way faster to develop and control and adjust rather than the hardware. Yeah. So where everyone else is controlling the modes of flights by hardware, we do that control by software. That was the main reason how to make the system actually reliable, efficient UAV platform ready to perform where others fail.
Well, first of all, I just remember the first time I ever saw the FIXAR drone, and it was the 007, and it was at some show, and it's just so unique. And I know you're, Basil, you're talking about how it was almost like build the software and the hardware will come, because the software is going to be the command and control. It's going to be, you know, help us with distance and everything like that. But just an amazing design. And so, you know, and it's the most obvious thing people see, right? When they walk down the aisle at a show, they look at this thing and they're like, wow, like, tell me more about this. So in terms of, and we'll dig deeper into the software, but in terms of like the really unique aerodynamic design of this VTOL, vertical takeoff and landing drone, you know, what problems were you trying to solve in that design? Because obviously you have the hardware and the software both.
Well, very good question, because actually the problem is complexity of the VTOL drones. They are either complex in terms of the control and in terms of transition from hovering to level flight and back transition from level flight to hovering and landing. With all the dependencies of wind gusts, with all the bottlenecks of dead weight of mechanical parts and etc. So, and taking that in mind, I had an idea that maybe we do not need to do that transition. Maybe we can fix the system somewhere in between so that we don't transit from multi-rotor mode to airplane mode.
Right.
And we don't do the back transition from airplane mode to multi-rotor mode. Let's have the system as one where it combines both. So that means that FIXAR VTOL systems, they don't transit. Why? Because they don't need to transit. They are both multi-rotor systems and airplanes simultaneously. They are quadcopters and fixed wing drones at the same time. Only the high level logic of the system of control changes, but you don't see it. So when you look at these unique airframes and unique aerodynamic designs, you see just the top of the iceberg,
Right.
because main part sits in the software, how to control the thing which does not do the transition, which actually is always both systems. That is the years of development which were needed to make it fly.
Well, that's amazing. And I know you've got one actually in the background there. And
Yes.
it's that triangular shape almost that I think makes it look so unique in terms of what everybody else is doing. And maybe that's a great thing to kind of put over to Maggie now on the market side, because you've, like you said, Maggie, you've been interviewing companies for years. You've gone to all the right shows. You fly drones. You know, on the market side, what would you say? What are the pain points that these FIXAR drones are actually solving?
Well, first of all, do you mind if I back up a little bit?
Yeah,
In
sure.
regards to FIXAR, just the company's name stands for fixed angle rotor. So Vasilii was describing why it's fixed, that aerodynamically, there's a lot more parts when you have a moving rotor, and having it fixed and the aircraft actually transferring from hovering from the vertical to the horizontal is key. And again, as a visionary, he saw that and he solved that problem so that the energy itself goes into the flight, not so much into the transition. And so that's important. And secondly, just so you understand, I want to break down the company a little bit more. FIXAR is a not only a creator. They focus on the design of an aircraft. That is their main focus. Second part is the actual the brains of the mission control and the autopilot, and how they work hand in hand with the aircraft. And then the third part is the payloads. And FIXAR's not by the way, FIXAR's not designing payloads. What they're doing is they're integrating payloads that are available. So you have a lot of customers that have, certain missions, operations, they're focusing on collecting data, they're focusing on delivery, whatever that may be. The thing about FIXAR, it is very unique, is that they customize to the customer's needs. So I think that that's really important to clarify. So, like if somebody has, for instance, I was at the Energy Drone and Robotics Summit, and we had a lot of end users there with oil and gas and utilities. And their main point is, we need to inspect these pipelines. So we would work with the payloads themselves to integrate with the aircraft. And what's so unique about this aircraft, of course, you can take off and land in almost anywhere. And then it flies horizontally, which means it uses, because of the aerodynamics of this design, it can actually fly more effectively and longer. And the biggest thing about, as a pilot myself, is, I only have 15-20 minutes key to collect this data, because I got to bring it down and change the battery and go back up again. And that takes a lot of time. And it's getting to the point where beyond visual line of sight is going to be necessary for these operations. And you don't want to have a drone or an aircraft that's collecting this data that keeps needing to be landed for a switch of batteries. So that has been Vasilii's main objective, is the problems that are here today is, number one, safety. FIXAR is all about safety. And they want to make sure that, especially when there's areas that are dangerous, like, inspecting a high tower or something like that, detecting gas, you don't want to put people in danger. And so that was the one thing that Vasilii did, is focus on this new platform that replaces people in dangerous situations. So that's number one. And then again, the other problems that he addressed is longevity. Something that's going to fly and collect the data, and you don't have to interrupt because you have to change a battery. And then thirdly, I think it's so important with this new technology, with especially the 025, that it not only, and we'll go a little deeper into it, but not only does it fly a long time, 3.5 hours, but that it can actually carry more than one payload. And I'll let Vasilii tell you all about it. But those are the issues that he's really addressed. We're number one, with this new industry, we're replacing manned aircraft for unmanned aircraft. So we're keeping everyone safe, right? And we're being more efficient. It doesn't cost as much to put a helicopter, to put a drone out there as a helicopter. And I'm probably talking to people that already agree and already know that, but that's really important. That was the one thing that he wanted to address. The second is trust and compliance, operating again beyond visual line of sight, which is very, very prominent right now. Everyone wants to be able to do that. With the FAA cooperating, it's going to be more possible, especially with this new administration. We need to show that these drones, these automated autonomy drones are safe up in the air and can do the mission. And that's another thing that Vasilii is really focused on, is making this mission plan autopilot trustworthy, reliant. And the communication is there, and we can go dive deeper into exactly what that means. And then third, the logistics, public safety. I mean, you think about, again, public safety, utilities, oil and gas, law enforcement, agriculture is huge. And you want something reliable. You want something that if you put in a mission plan, if you say, okay, I want you to check this field for any plants that are distressed, or if there's a drought, because again, we found infrared a fantastic tool to see where there's drought or where it's overwatered. Those are things that are reliable. So once you put this in the mission, once you see these issues and these problems, and you find that one aircraft, one drone, one program, one company can solve these problems, it's just a no-brainer.
Well, yeah. So thank you, Maggie. That was a great explanation. And I'm going to go back over to Basil because Maggie mentioned, two key things when you think about drones today. Mission safety, of course, is always a priority, and autonomy, which, that enables scalable, repeatable operations for a whole range of market use cases. So Basil, how does FIXAR software and AI technology enhance those two things, UAV technology, autonomy, and mission safety both?
Well, actually, for me, autonomy equals safety, because when you look at even a general aviation emergency situation cases, 80%, or I would say more than 80%, based on the statistics, yes, actually human factor results. So less human intervention is to the system, the more robust and reliable the system is, which means autonomy, if it is cooked in the right way, is the safety, or it is the tool how to approach the safety. Meanwhile, we must understand the technological layers where the artificial intelligence is useful is not the low level, it's the high level of the system. The low level of the autopilot system is still the real-time decision-making algorithms on board. So this is mostly math. When we speak about data processing and use cases implementation and use case scenarios implementation, when the computer vision system, for example, needs to be a replacing part in GPS-denied environment flights. This is the approach for safety, where the artificial intelligence is reasonable to be used. When the high-level big data processing is being done on board, and because of the results of this real-time data processing, the command is given to the low-level system of the autopilot to change the route or to chase the target, or some other use cases and implementations are possible. In this way, for example, as one of the next steps, which is technologically already here, but on the regulation part not yet, yeah, you know that, that actually the mission control can be done on board without having the pilot or the operator on ground, where the artificial intelligence will replace the ground operators which are now there mostly because of the regulations.
Right.
And this is also the part of the BVLOS regulations, and this is also the part how we need to tell to the authorities that the technologies, they develop faster than they bring the regulation rules. And this is a key point, how to bring the autonomy and safety to the UAV industry. Meanwhile, at the moment, we have an approach with low-level autopilot system, which is developed by FIXAR for FIXAR, meaning proprietary, no open source, which means data safety. And the high-level AI system, which analyzes the data from the sensors on board. And this helps the system actually work in harsh environments, in GPS denied environment, and even when you have night flights and in GPS denied environment, this computer vision system can help you implement the mission fully autonomously. It can also help you with the use case implementations and the other scenarios where the camera by control is implemented. When you track the object, for example, by the camera, and the coordinate of this object is directly given to the autopilot, and then the system is starting to follow the ground, for example, vehicle or the ship or the boat or like whatever. Yeah, this is where AI sits. Meanwhile, we have the autopilot proprietary developed by FIXAR based on the control by software, what others control by hardware. We have the proprietary radio communication protocol, which is used for telemetry and video stream online in cases of search and rescue ISR operations.